Hello guys, this is Astha Sharma from MTech IT 2K21 batch. Let's continue our discussion on data science paper of internal 3. Here we go. Question number 1. Discuss attribute by attribute problems that may found in the following data. Let's start our discussion. Consider a training data set where some types of error that could occur. Can you find any problem in this data set? Uh, let us discuss attribute by attribute some of the problems that have found there. The customer ID variable seem to be fine. Attribute of zip, where we are expecting all of the customers in the data set is the data set to have the visual 5 numbers. US zip code. First, the customer 1002 is okay. Now, customer 1002 has zip code of J2S7K2. Usual value may be an error and toss it out. Not all country use the same zip code. Actually, this is the zip code of Saint Hyacinthe from Canada. So probably represent real data from the real customer. The customer 1003 is okay. For customer 1004, we are unaware of any countries that have 4-digit zip code, such as the 6269 indicates here. So this may zip code for the New England states begin with their numeric 0, unless the zip code field is defined to the character text, and which is apparently what happened here. The zip code is probably 06269, which refers to Storer's Connecticut. Gender attributes contains a missing value for customer 1003. In income field is measuring annual gross income has 3 potentially anomalous values. Customer 1003. Income of this per year possible, especially when considering the customer's zip code 10210 Beverly Hills. This value of income is neither less an outlier and extreme data value. Certain statistical and data mining models technique do not function smoothly in the presence of outliers. Poverty is one thing, but it is rare to find an income that is negative as our poor customer 1004 has. Customer 1004 reported income of 40,000 lies beyond the field bound for income and therefore must be an error. It is unclear how this error crypted in, with perhaps the most likely explanation being that the negative sign is the stray data entry error. However, we cannot be sure and should approach this value cautiously. Attempting to continue with the database manager, most of us for customer 1004's income of 99 is not a round off. Perhaps it may in fact be valid, but if all the other incomes are rounded to the nearest 50,000 code for anonymous entries such as missing values, perhaps this income was coded in an old database to mean missing. Finally, are we clear as to which unit of measure the income variable is measured in? Database often get merged, sometimes without. For example, it is quite possible that customer 1003 with a Canadian zip code has an income measure in Canadian dollars, not in US. The age field has a couple of problems, although all the other customers have numeric values of age. Customer 1001's age of C probably reflects an earlier categorization of this man's age into a bin labeled C. The data mining software problem somehow. Customer 1004, age of 0. Perhaps there is a newborn male living in Stores, Connecticut, who has made a transaction of 1000. More, the age of this person is probably missing and was coded as 0 to indicate this or some other anonymous condition. The Martial status field seems fine, right? Maybe not. The problem lies in the meaning behind this symbol. We all think we know what this symbol means, but are sometimes surprised. For example, cold water in a rest room in Montreal and turned to on the Foctel marked sea. Since the C stands for cod, which is French for hot. Thus, there is also the problem of ambiguity. In about tables, does the S for customer 1003 and 1004 stand for single or separate? Like in transaction, the transaction amount field seems satisfied as long as we are confident that we know what unit of measure is being used and what all records are transacted in this unit. Now, question number two, apply data wrangling process in following data, like in name, in phone number, birth date, and status. Let's start our discussion in question number two. Here, a data wrangling process is done. Like all names are formatted the same way, first name and the last name. All comma and other such problems are removed. Like in phone numbers are also formatted the same way, area code, ABC, and and the numbers, rest of the numbers, like this brackets and other such kind of problems are avoided. In dates are formatted numerically, like in year, first year, then month, then date. Status are not abbreviated. The entry for Zaki Agrawal did not have fully formed data. The area code on the phone number is missing and the birth date had no year. So it was discarded from the dataset. Now that the resulting dataset is cleaned, readable for deployment or evaluation. Now the question number three, consider following database, apply any three for finding out missing values. Let's start our discussion for question number three. Replacing missing field with random draws for the distribution of the variables. In table D, serial number 2, cubic inches. Cubic inches is replaced by 450 and brand is in brand serial number 4 is replaced by Japan. Uh, by second process, replacing missing field with user defined constants, like in cubic inches serial number 2, table B serial number 2, we replaced cubic inches of serial 2 by 0 and brand of serial number 4 with missing, which is a type of string. Replace by process 3, replacing missing field values. We do cubic inches data's mean. So in serial number 2, we do the mean of the whole cubic inches, and in brand, we see the most common value which occur again and again, and we put this on this place. Question number 4, classify bank loan application by assigning application to one of the three risk classes. Use entropy and information gain approach. And question number 5 is same as compare the attribute for classification of bank loan application by assigning application to one of the three risk class. Use Gini index and information gain. Let's start our discussion for question number 4. Decision tree using the information measure. Using the information measure, training data sample 1 to classify bank loan applications by assigning applications to one of the three risk class. Here we have table given number of examples, that is 10, and number of classes 3. Frequency of class A is 3, frequency of class B is 3, and frequency of class C is 4. Overall information in the given data due to uncertainty of outcome regarding the risk class each person belongs to is given by by the information which is present on the screen. Let us consider using each attribute in turn as a candidate to split the example. Owns attribute 1 for owns home. For value y, there are 5 applicants whose owns home. They are in classes A is 1, B is 2, and C is 2. Values n, there are 5 applicants who do not own home. They are in classes A equals to 2, B equals to 1, C equals to 2. Then we find out the information gain by applying the formula. Total information gain of the two subtrees is 1.52. According to this attribute 1, we apply this process on each attributes. Attribute 2, which is of merit, attribute 3, gender, and attribute 4, employed, and attribute 5. And we concluded the values information total information of two subtrees. Now we can reduce the data by removing the attribute gender and removing the class B, since all class B has gender equals to male, because the gender has the smallest information gain value. So this is the root node of it. Now we can reduce the data by removing. um, Now we have the data of new table which contains owns home, married, employee, credit rating, and risk class. So the gender is the root node. We eliminate it and put it into the decision tree. Like information gain by applying formula, we uh, so the answer is 1.33 of information gain. Let us now consider each attribute in turn as a candidate to split the sample. Uh, as mentioned above, apply apply that processes on this. Attribute 1, attribute 2. Attribute 1 is owns home, attribute 2 is married. There's no need to consider other attributes now because no other attribute uh, can be better. The split attribute married will be used to split attribute. So the second root node is married because information gain of married is 0 and information gain of owns home is 1. So the root node is married. By applying the same formula, uh, we concluded the root node and the child node. The rule: if gender equals to male, then class B. Else, if married equals to yes, then class B. Else, class C. Now, the question number uh, fifth, we have given this table and the values, number of examples S equals to 10 and number of classes 3, number of frequency A equals to 3, frequency of class B equals to 3, frequency of class C equals to 4. First attribute owns home. For value y, there are 5 applicants who owns home. They are in classes A equals to 1, B equals to 2, C equals to 2. Value equals to n. There are 5 applicants who do not own home. They are in classes A equals to 2, B equals to 1, C equals to 2. Then Gini index, we calculate Gini index. Total value of Gini index is 0.64 of owns home. Attribute 2 married's Gini index is 0.40 and attribute 3 gender whose Gini index is 0.358. Attribute 4 employed's Gini index is 0.475, and for attribute 5 credit rating, attribute 5 credit rating for value A, we do the same process and total value of Gini index of the two subtree are is 0.64. Now we obtain the second node. Uh, then the rule is if gender equals to male, then class B. Else, if married equals to yes, then class C. Else, class C. And we have this, and we obtained this decision tree. Thank you so much.